observe the current that actually flow through the filament. The purpose of this one is to produce the brightness on the screen, because when you increase the temperature of the filament, what happens is there will be more thermal electron being produced. Okay, so this is our filament part, and then nearby to the filament we have a cathode. Okay, we have a cathode. Okay, this cathode is for the purpose to produce thermal electron on this side here. Okay, so this is our thermal electron on this side here. Okay, but this thermal electron, they are moving in random, and then okay, in between the the cathode here, okay, in between the cathode and the accelerating anode, we have something that we call the grid. Okay, the grid. This grid is something like a mosquito netting. Okay, is something like a mosquito netting. The purpose of the grid is to control the number of electron that can pass through. Okay, the number of electron that can pass through. Just like, for example, the grid is mosquito grid or mosquito netting is used to control the number of mosquito that can enter your house. If possible, we don't want any mosquito. I have a mosquito here now flying around. Okay, so now that is a grid. I will label later. Now I explain first, and then at the same time, okay, we need something to accelerate the electron. So we have this accelerating anode. Okay, accelerating anode. So it is in the shape of cylinder. Okay, it is in the shape of the cylinder. So hopefully I have the same size that I want. Okay, so it's more or less like this. Okay, all right, and then close this one. This is one of the cylinder. All right, so now our cylinder is connected to a positive power supply. So the electron will be passed through in between, but we need more than that. Let's say we draw two of the cylinder. The purpose is to accelerate the electron multiple steps. Okay, so that it's more efficient that way. Okay, another cylinder here. Okay, now close the cylinder. Okay, so now we have two accelerating anodes. So these two accelerating anodes are at different voltage. The voltage here is higher than this one, so that after accelerating in between the cylinder, they'll be accelerated again one more time. In a real oscilloscope, there might be 1, 2, 3 or more, depends on the power that you need. Okay, so that is our accelerating anode part. Okay, so now I will label that part first. So this one is the filament. Okay, that one is our filament. And then this one is the cathode. And this one is our grid. Okay, that is the grid. Control grid. We call it control grid. Okay, to control the number of electrons. And then come to the next one. Both of this one, okay, both of this is the accelerating anode. Okay, accelerating anodes. And now, after accelerating, yes, the electron will be very fast, but they are still quite a big cross section. You can see that the electrons are from this area here, so they come out very fast, but they are still quite big. Okay, the cross section of the electron beam is very big. So what we do is we need to compress that one. Okay, to compress the beam. So to compress the beam, we need another type of what we call that, the cylinder. Okay, so this accelerated a compression, okay, to make the this cross section become smaller. It is called focusing. Okay, focusing. So this focusing is also cylinder. It is also a cylinder, but the other end of the cylinder will be slightly smaller. Okay, so that means this part here, the cylinder is smaller. Okay, is smaller. So it seems like there is a hole here, okay? And this hole here is inside here. So I draw using dotted line. There's a smaller hole here, so I use dotted line here. Okay, so you see there's a smaller hole here. So that means the electric field will actually compress the electron, become smaller and smaller. So normally we need more than one as well. Okay, so the next one here is going to be even smaller. Okay, so the front part of course is big, okay, but the opening is small now. The opening is about the size of the first cylinder, okay, the first one. So I mean this is the opening, okay, the opening, so the electron can pass through, right? And then when come to the exit, when it come out, okay, when the electron come out now from this, it's going to become even smaller. Okay, this one I don't know how to draw it. Hopefully this one is small enough. So this one will be even smaller. Okay, so now we see that from this big hole, it go to the smaller one, and it becomes smaller and smaller. If you want to make it even smaller, you need another one, so that it becomes smaller and smaller, so that the beam from this size is going, from this size, the beam which is from this size is going to end up become very focused and very tiny beam. Okay, so you can concentrate all the electron in a very small cross section. Okay, so that is the what we call the focusing part. Okay, the focusing part. All right, so now this focusing part is also connected to power supply. Okay, it must be connected to power supply, must be different power supply. So this power supply we will call V positive, this one will V positive, positive here, and then the same thing here, V prime positive, this one V prime positive, positive. Okay, so these two is the focusing. Okay, the focusing anode. Okay, the focusing anode. Okay, focusing anode. And then after focusing anode, that means from now on the electron are accelerated, okay, in this manner. Okay, in this manner, and become very fast thanks to the accelerating anode. Okay, and then by the time it reach here, okay, it will become smaller. See or not? It becomes smaller and smaller, more or less like this. Okay, it become like this and then smaller, come out here, and now by the time it reach here it's even smaller, so it's only come out as a single beam. Okay, single beam come out only. So that means here it is all electron, 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 and then by the time it reach here it become one single line only, very focused one. Okay, very focused one. So we need also, if there's nothing here, this electron beam will hit the screen at the center, okay, at the center of the beam, and it gives us a dot. Okay, gives us a bright dot, and then the color depends on what you have. If your fluorescent screen is coated with different material, then the color that you see on the oscilloscope will be different. Okay, so it's either greenish in color or orange in color. It depends. Well, nowadays there are so many types of material can be used, so the color can be different, depends on what you have. All right, so next part is we still need to extend. Okay, we still need to extend this oscilloscope. Okay, next part is we need to be able to control the movement of the electron beam, horizontally or vertically. Okay, horizontally or vertically. So first one is our horizontal movement. The horizontal movement of this electron is controlled by our X plate. Okay, our X plate here. Okay, our X plate. Our X plates, we have two pieces. Okay, we have two X plate around. Okay, I draw a little bit of a three-dimensional so that you can see. So this X plate are connected to two electrodes, one from each side. Okay, so that is our X plate. So this X plate is used to control the electron beam horizontally. So we call this one the X plate. Okay, X plate. Okay, X plate. So they use X plate simply because horizontal axis is X. Okay, horizontal axis is X. And then when the electron come out from here, okay, after being controlled by the X plate, it now enter the Y plate. And your Y plate are placed horizontally. Okay, horizontally. So one at the top, another one at the bottom. Okay, another one at the bottom. Okay, so these are the two Y plates. Okay, these are the two Y plates. So we have electron beam. After passing through the X, now it will enter the region of the Y, and you can see a little bit here, and then it come out from the Y. Okay, come out from the Y. So this X control the horizontal movement, and then this Y plate control the vertical movement of the electron. So this one here is called the Y plate. Okay, the Y plate. Okay, the Y plate. So I might as well use arrow here, 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 this one and this one. Okay, so that is our control. Okay, that is our control for the electron beam. Okay, and then by the time we reach here, the last part will be our screen. Okay, our screen here. So I need this. So starting from here, electron beam, this is our screen. Alright. Alright, so that is our screen. And this screen is coated with fluorescent material. Okay, it's coated with our fluorescent material. Well, I just using some dotted line. Okay, so some of the dotted line. So forgot not dotted line. So we have this darker area represent this fluorescent screen. Okay, so that is our fluorescent screen. So the purpose of the fluorescent screen is to produce light. Okay, so this is our very thin fluorescent screen. Or fluorescent coating, okay, inside there. So when electron hit, say, it produce light. Okay, it will produce light. So this is our electron beam now. So electron beam now successfully hit the screen, okay, and produce light here. And everything inside here must be in vacuum. Alright. So that is how our oscilloscope work. Okay, this is how oscilloscope work. So now we are going to look at how it functions, starting from you switch on the oscilloscope or the CRO. Okay, so why in this case we don't have this VLT? Of course, the VLT compared to the previous one, if you look at our previous one, there is a VLT between here. But in this case, we don't have a cross. We don't have a cross here, so our VLT is connected to this one, the V plus, V plus plus, V prime plus, and also V prime plus plus. And that is where you connect the VLT here, because this is not multi-cross, okay, tube, okay, not multi-cross tube. This is a actual cathode ray oscilloscope, and this is the basic technology for the olden day television. Remember the television that have a something like this? Okay, the television something like this. The screen is here, huge, very heavy, and then behind here you have something very heavy like this, and the screen will be bowed out a little bit. Why? Because of the curvature of the screen. If you put flat one, the image will be distorted. Okay, so if you carry this type of television before, you know that it's damn heavy. Okay, and nowadays there are seldom people using this type of television already, because the flat screen one is like very common, and actually the price are quite competitive. Okay, that means they are actually quite cheap, quite affordable nowadays. Even the computer screen nowadays are mostly what we call that, the LED screen, including the telephone screen like this one. Okay, so that is the basic one. And nowadays that means the technology for oscilloscope already changed. Okay, we have some other oscilloscope that is actually based on LCD screen, which is actually much efficient because they don't consume that much energy, and they don't need to operate at high temperature. Okay, so that is the basic about oscilloscope. Now we now look at the step, how it function. Okay, how it function. So we use step 1, 2, 3 to show how it works. Number one, filament is heat up to increase the temperature of the cathode. This one, filament heat up to increase the temperature of the cathode. So when cathode is heat up, temperature increase. Now the hot cathode will produce thermal electron. Okay, it will produce thermal electrons. Okay, thermal electrons. And then this thermal electron will pass through the control grid. Okay, control grid. All right, and then after passing through the control grid, thermal electrons will be accelerated. Okay, will be accelerated by the accelerating anodes. Okay, maybe one or maybe two anodes. And then number 5, then the accelerated the high velocity. Okay, then the high velocity thermal electron will be focused. Okay, will be focused to a smaller cross section. Okay, cross-sectional area. Okay, cross-sectional area. So what happened next is number 6. Okay, the focus beam or electron beam, the focus electron beam, or this electron beam actually is our cathode ray. The focus electron beam will bypass the X plates and Y plates. Okay, and Y plates. Then finally the beam will hit the screen and produce a dot or a spot of light. All right, so that is basically how oscilloscope function. Okay, so the next one will be the next video will be about how the control on the oscilloscope actually control the up and down and the movement of our electron. Okay, wait for the second video.